Binary encoding. Binary encoding is a technique for encoding categorical variables by representing each unique category as a binary number. This binary representation is then split into separate columns, where each column corresponds to a binary digit, 0 or 1. If we compare it with one-hot encoding, it creates a smaller number of new columns, thus reducing dimensionality of dataset. Now, what are its advantages? Reduced dimensionality. Compared to one-hot encoding, binary encoding requires fewer columns, especially for high cardinality data. Retains information. Encodes the ordinal relationship between categories due to the integer to binary mapping. Handles high cardinality. Well, more efficient for datasets with many unique categories, as it reduces the risk of sparsity. Improved model performance. Fewer dimensions and more compact representation can help some models, tree-based algorithms, perform better. Now, what are its limitations? Loss of interpretability. The binary representation isn't human-readable and may obscure the original meaning of the categories. Potential for information loss. The conversion to binary may lose some relationship nuances between categories, depending on the dataset. Model sensitivity. Linear models might not interpret the binary splits effectively, leading to suboptimal performance. Now let's take a quick look at our toy dataset. We will take the temperature category. The first step is to set the order. Note it's not ordinal values, rather the order in which categories are in the dataset. Here, hot is 1, cold is 2, and so on. Now these numbers are converted to binary value. Since the highest order is 4 here, we will need 3-digit binary number. Finally, from these 3 digits, 3 columns are created with respective 1 and 0 for each column. Now, let's dive into the Python code to see how to implement binary encoding. We will be using Python libraries pandas and category encoders. Here is the toy dataset we'll be working with. It has 3 columns: temperature, our categorical variable, color. An additional column we want to encode in this example, target, our target variable which we're trying to predict. First, we create a data frame to load the dataset. We initialize the binary encoder with the column temperature. Then we do fit transform to apply the binary encoding transformation for the temperature column. Then finally, concat the columns created with the data frame, reindex it, and create a new dataset. When we display this data frame, we'll see 3 new temperature columns are created as expected with corresponding binary digits. If you're enjoying this video and finding value in it, don't forget to hit that like button. It really helps me to reach more people like you. And if you want to keep learning and exploring exciting topics like this, make sure to subscribe and turn on the notification bell so you never miss an update.